Hello, so now that we've talked about unit conversions, mole-to-mole ratios, and molar mass, we can finally talk about stoichiometry problems. Stoichiometry is just a fancy word for figuring out the exact recipe for a chemical equation or a chemical reaction. So how can we do this? Before I show you an actual problem, I want to show you the tool that you'll be using to solve the problems. It is this nice, simple diagram. Sometimes a question will give you the grams of the reactant in a chemical equation, and this diagram will show you how to get to different types of quantities, how to unit convert to different things that you need. So if you get grams of reactant, but you want to know how many moles of reactant there are, to do that unit conversion, you just follow this black line here where it says divide by the molar mass of the reactant. That's how you convert grams to moles. That should sound very familiar from last exam because we had to do that. Now here's something new. How do we go from moles of reactant to moles of product? Well, that's why you learned about mole-to-mole ratios using sandwiches. To do that, you take the moles of the reactant in the equation, divide it by the mole-to-mole ratio of the reactant and the product. Remember when you made a fraction or a ratio of the number of slices of bread to the number of slices of cheese, for example? Instead of bread and cheese, you're going to be talking about products and reactants of a chemical equation. And then when you divide by this mole-to-mole ratio, this fraction, you're going to get moles of the product. And just like before, sometimes the question will ask you for grams of the product. And in order to go from moles to grams, you multiply by the molar mass of the product. Sometimes these things are better explained with an example. So let's use water. How many grams of water can I make from 25 grams of hydrogen gas and an excess of oxygen gas? And using the reaction 2H2 plus O2 yields 2H2O. The scary thing about this question is an excess of oxygen gas. That just means you have infinite amount of oxygen gas to use. How much water can you make from 25 grams of hydrogen gas and an unlimited supply of oxygen gas can I make? So how much actual water molecules, how much grams of water molecules can I make? So we have to take this problem step by step. And the first step is to use our diagram to indicate the given. So what number do I already know, and determine the unknown. What number do I want to know? And so you can do a quick sketch of your diagram and you go, okay, how many grams of water can I make from 25 grams of hydrogen gas? So I know already that I have 25 grams of hydrogen gas, and that is a reactant. So that's where I would start. That's the given that I have to work with, and I'm going to convert from grams of this hydrogen or reactant to get my unknown, which is how many grams of water. So water in this equation is a product, so it's going to be one of these green boxes, and it says how many grams, so it's going to be this last box right here. So I want to start with grams of reactant, and I have to do conversions until I get to grams of product. Alright, so that's just step one. Step two, we're going to move one box closer to the unknown. So from grams of reactant, the next thing I can convert to is moles of the reactant. So I know 25 grams of hydrogen gas, I need to convert that into moles of hydrogen gas. So here's something similar to what we learned about in the first part of today's class. So I have 25 grams of hydrogen. I'm going to set up my T-chart method, and I know that hydrogen has a molar mass of 2 grams per 1 mole. And I want hydrogens to cancel, grams of hydrogens to cancel, so I need to put 2 grams of hydrogen on this bottom part of my T and 1 mole of hydrogen at the top because I want the answer in moles right now. All right, that's step 2. Step 3, we're going to move another box closer to the unknown. So we found moles of H2, and now I want to know how many moles of water there is. And in order to find that, I need to use the mole-to-mole ratio between H2 and H2O. So here I've just kept the setup from the last problem the last step, and I can add another T. Okay, now I can do a mole-to-mole ratio. For every 2 hydrogen gas molecules, I get 2 water molecules. So 2 moles of water over 2 moles of hydrogen. 2 moles of hydrogen goes on the bottom because I want to cancel moles of hydrogen here. We're trying to get to grams, so I don't need moles of hydrogen. I need grams of water, and before I can do that, I have to get moles of water. Step 4 finally gets us to our unknown answer. We'll put up our diagram again. We have moles of product or moles of water, and we just got to convert that to grams of product. So how would I do that? Well, I'll put this back up here. I had 2 moles of water from the last step. Now I'm going to look up the molar mass of water, which is 18 grams of water per mole. Mole goes on the bottom because I want to cancel the units moles of water. And 18 grams of water goes up top. And to finally finish the problem, we're going to multiply all of these numbers up top, which is 25 times 2, or 25 times 1 times 2 times 18, which gives you 900 grams of water divided by 2 times 2 or 4. And when you do that, that gives you 225 grams of water. So we finally answered this question. How many grams of water can I make from just 25 grams of hydrogen gas and an excess of oxygen gas? I can make 225 grams of water. When you come into class next week, I will give you an explanation of why we need this skill, but what I want you to work on today, the rest of today, and over the weekend is just practicing this skill of using unit conversions to solve these types of problems. And then I will explain to you how we're going to tie this in with petroleum and fuels and energy.